Hello class, welcome to this next lesson in 8th grade Eureka Math. We're in Module 7, Lesson 3, called Square and Cube Roots. So we talked about square roots in the last lesson, Lesson 2. We're going to review square roots, go a little bit deeper into square roots, and also talk about cube roots today. So you'll need pages 25 through 33 in your Module 7 workbooks. And you'll need your notes, of course. So let's begin. We have vocabulary to start with, and we have 3 terms in the vocabulary list today. Radical, which I believe we saw in Lesson 2. Square root, which was in Lesson 2. And cube root, which is the new one today. A radical is the symbol for taking the root of a number. So it's this symbol right here. The red one right here, that is the symbol we use for square root or cube root, or fourth root or fifth root, whatever. Any root you take, that is the symbol for root. It's a radical. A square root is a number multiplied by itself to form the original number. Like 2 times 2 makes 4, so 2 is the square root of 4. 3 times 3 makes 9. So 3 is the square root of 9. So that's a square root. A cube root is similar to a square root, but this time it's a number multiplied by itself 3 times to form the original number. So for example, the cube root of 8, and this is how we do cube root. We put a 3 in the radical on the radical, because it's cubed, and cubed means 3. The cubic root of 8 is 2, because 2 times 2 times 2 equals 8. So it's the number multiplied by itself 3 times. So square root is only 2 times, cube root is 3 times. So 2 times 2 times 2 makes 8. That's cube root. So today what we'll be doing, we will learn how to review square roots and to learn how to solve cube roots. That's what we're doing today, reviewing square roots. So we will see square roots again, and we're going to learn about cube roots. Now let me give you some notes about how to find cube roots, a little bit more details. So here we go. Cube roots, we have the radical, and there's a 3 for a cube root right there. So we have a 3. That's the difference between square root and cube root. Square root, there's nothing in the radical. Really, there probably should be a 2. But mathematicians have just agreed that the radical with nothing right here means square root. If it's a cube root, you need a 3. And this is the number we're taking the root of. So what we get is you have to think something times something times something makes the original number. And the number that gets repeated, that's the cube root. It's multiplied by itself 3 times. And here I have an example with 27. The cube root of 27 is 3. The cube root of 27 is 3 because 3 times 3 times 3 makes 27. There's 3 of them because it's a cube root. When we did square root, there were only 2. Cube root, there's 3. That's the difference. Just like in the last lesson, I gave you a chart of common square roots. I'm also giving you a chart today of common cubes and cube roots. So here's a few. I went all the way up to 15. So if you need to pause the video to write some of these down before I move on, go for it. But you should be able to see 1 through 8 on your screen right now. 1 times 1 times 1 makes 1. So the cube root of 1 is 1. 2 times 2 times 2 makes 8. So the cube root of 8 is 2. 3 times 3 times 3 makes 27. So the cube root of 27 is 3. And so on. Like the cube root of 64 is 4. The cube root of 125 is 5. The cube root of 216 is 6. The cube root of 343 is 7. The cube root of 512 is 8. And I'm going to slide it up. So if you need to go back and pause to write down this list, do that. This list will help you on today's work. So make sure you copy it down and have it next to you today. So let's move up here. Here we go. Cube root of 729 is 9. 10 is the cube root of 1,000. 11 is the cube root of 1,331. 12 is the cube root of 1,728. 13 is the cube root of 2,197. You can see how fast it's growing. 14 is the cube root of 2,744. And 15 is the cube root of 3,375. You are not expected to memorize these. I do not have these memorized. I think the biggest one that I have memorized is up to 5. But you should be able to figure them out. I'm giving you the paper as kind of a tool that you can use to help you. There's also always the guess and check method that you can use. But these are the first 15 cube roots. Now let's practice with this a little bit. Let's get to our lesson starting on page 25. And page 25 is a little opening exercise where they tell you that there are 2 columns and the numbers are related. So you have to find the rule that changes the left number into the right number. So let's just focus on the first box right here. The first table, the first chart. Find the rule part 1. 1 turns into 1. Well, there could be a bunch of different options for us. It could be 1 times 1, 1 plus 0, 1 minus 0, 1 divided by 1. We just do not have enough information yet. They do give us both numbers for 3. How does 3 turn into 9? Well, 3 times 3 makes 9. But that cannot be our rule, because 1 times 3 does not make 1. So we cannot multiply by 3. How does 11 turn into 121? Well, that's 11 times 11. So this one is 3 times 3. This one is 11 times 11. This looks like 1 times 1. So the rule seems to just be take this side and we square it. Seems to be a square. So if we want to go that way, we need to square what we're doing. Because if we move to the right, we do 3 squared makes 9. 11 squared makes 121. 1 squared makes 1. So that should help us figure out some of the missing numbers. So 2, and remember the rule is squared going right. 2 squared is 4. 15 squared is 15 times 15, which I believe is 225. But I should actually check just to make sure. I don't want to lie to you. So let's check. 15 times 15, 15 squared is 225. 10 squared is 100. 12 squared is 144. And m squared is m squared. So that helped us fill out all the ones where we have to go right. What about if we want to go left? What's the rule going back? Well, how does 1 turn into 1? How does 4 turn into 2? How does 9 turn into 3? How does 121 turn into 11? This is the square root. So we have to take the square root to move left. So moving right was squaring, moving left was square root. So the square root of 81 going left is 9. The square root of 49 is 7. The square root of 169 is 13. And the square root of n, we can just say, is the square root of n. So that was finding the rule for that column. We had to think about it. What about part 2, find the rule? We still have 1 turning into 1, but this time 3 turns into 27, 6 turns into 216. What is happening with this number? Well, what is the same rule that makes 3 turn into 27? Because I know 3 times 9 makes 27, but 6 times 9 is not 216. So what's going on? You might be confused until you look at the notes you took with this list of cube roots. Because 3 makes 27. 3's make 27. 6's make 216. 6's making 216. So you can see in this chart, the rule to go right, we are actually cubing the number. We're cubing the number to go right. So 2 cubed, 2 times 2 times 2 is 8. 11 cubed, I'm going to look at my chart. 11 cubed is 1331. 10 cubed is 1000. 7 cubed is 343. And p cubed is just going to be p cubed. Well, that works. It matches, it makes all our rules. So if we are cubing when we go to the right, that means if we want to go left, like for 125, 64, and 2744, we're not going to cube. We're going to do the inverse of cubing. We're going to take the cube root, which is a radical with a 3. So cube root. So what is the cube root of 125? If you don't know, you can look at your chart. The cube root of 125 is 5. What's the cube root of 64? The cube root of 64 is 4. Now you see why my chart comes in handy, and you should have copied it down. If you did not copy it down because you did not think it would help you, go back in the video and copy it down now. What's the cube root of 2,744? The cube root of 2,744 is 14. And what's the cube root of q? Well, we don't know what q is, so we just say the cube root of q is the cube root of q. So that is how we found the rules. The red in part 1 was squaring and square roots. The blue for part 2 was cubing and cube roots. So you get a little bit of experience practicing with these skills and recognizing them. Now let's move on to our exercises and get some more practice in with these. Here we go. Exercise 1 on page 26. It says, find the positive value of x. So this is a positive value. Remember, square roots can be negative because a negative times a negative still makes a positive, but we are just worried about positives today. The positive value of x that makes it true. So it says x squared equals 169. We need to take x squared equals 169. So how do we find x? We want to find x. Well, what's the first step? Well, if I have x squared equals 169, the first step is take the square root of both sides. Take the square root of both sides because I don't want x squared, I just want x. So I start, let me show you in part B how I solve this. I start with x squared equals 169. Then I take the square root of x squared and the square root of 169. It's important that I take the square root of both sides Remember, because it has to be equal. Equal means the same thing on both sides. So if I do something over here, I do it over here. Now the square root of x squared might help you if you look at the chart we just did. The square root of m squared was m. The square root of m squared is m. That's on our chart. Remember, we did m squared to make, we squared m to make m squared, going right. But we can also go left. The square root of m squared is m. So the square root of x squared is x. And the square root of 169, remember you can use your chart from lesson 2. Square root of 169 is 13. So x equals 13. Now it does tell us to check our answer, so you should check to see 13 squared equals 169. Is that true? When we do 13 times 13, does that equal 169? And you can use a calculator for 13 times 13, or you can write it on the paper. You can solve it like that, but you get 169 equals 169, check. So when x squared is 169, x is 13. That's how we do that. Let's look at exercise 2. A square-shaped park has an area of 324 yards squared. What are the dimensions of the park? Write and solve an equation. So let's draw a square-shaped park. So this is our park, and it says it's a square shape, so I'm going to draw a square. And the area is 324. I'm putting that in the middle. What are the dimensions? Now, dimensions, it means how long is it, what's the length, and what's the width. That's what dimensions means. Dimensions mean sizes. So because it's a square, we want to know length and width. So we need to write and solve an equation for this. So it wants us to know how long the length is and how long the width is. What's the length? What's the width? Well, it did say it was a square. And so for a square, the definition of square is all sides are the same. So x, 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 and x, because it's a square, all the sides are the same. So what is the area of how do we find the area of a square? Well, you should know from school that area of a square is length times width. Now we want the length and width, and we know the area. So let's substitute in this equation what we know. The area is 324. How long is the park? The park is x. How wide is the park? Well, it's a square, so it's also x. Which means the area 324 equals x times x, or x squared. That is our equation right there. This is the equation. That's what we had to write. 324 equals x squared. Now we need to solve it to find the length and width, because remember, we want the dimensions. So we know x squared equals 324. To solve this, the first step is taking the square root of both sides. I do that because the square root of x squared is just x. So now I can solve it. The square root of x squared is x. Now I just need the square root of 324. The square root of 324, I believe, I'm going to have to think about this. What is the square? I'm not sure if it is oh, this is where I need my notes. See, I forgot to take out my notes. It's 18, I believe. So yes, it is 18. I can even check. my guess is 18. Let me check. I have 18 times 18 makes 324. There we go. I should get my notes out to help me later, but I get x is 324. No, not, sorry. It was 18. X is 18 because 18 is the square root of 324. 18 times 18 makes 324. So x is 18, which means that's our other answer. So this is our equation. And then I solved it, and x equals 18. So the park is 18 yards long and 18 yards wide. Those are the dimensions. It's a square, so it's going to be the same length with the width. So this is how we can use square roots to find measurements of squares, of square areas. Number 3, right here, we have x squared equals 625 that they want us to solve. So x squared equals 325. So the first step, remember, we want to find x. Okay, so the first step is taking the square root of both sides to keep it equal. Because the square root of x squared is x, and the square root of 625 is 25, which you can know from your chart, or you can just memorize. At least I think it's 25. I'm probably relying a little bit too much on my memory here. Let me check. 25 times 25 is 625. So the square root of 625 is 25. So that is what x has to be. So we are practicing our algebra, practicing solving equations with squares using square roots. So far in this year, we've been solving linear equations where the exponents have been 1. Now we're solving equations with exponents of 2. And then for number 4, we're actually going to write and solve an equation where the exponent is 3, because let's look at that right now. Exercise 4, we have a cube with a volume of 27 cubic inches. So let me draw this cube. This is how I draw a cube. I start with a square, and then I give it some depth. So that's my cube. And if you want to see kind of the back of the cube, like if it's a glass cube and you can see all the sides, that's how I make it like visible. That's how I draw a 3D shape, a 3-dimensional cube. Now the volume of this cube is 27 cubic inches. So, and it's asking, what is the measure of one of its sides? What is the measure of one of its sides? Well, it's only asking for one of its sides because it's a cube. And the definition of a cube means that all the sides are the same. So the height is x, the length is x, and the width is x. Everything, every dimension is x, because it's a cube. So how do I connect the sides with the volume? Well, hopefully you remember that the volume of a cube is length times width times height. That's how you find the volume of a cube. Length times width times height. Because it's 3-dimensional, we have to measure 3 dimensions, length, width, and height. So let's substitute to write our equation. We know the volume is 27 because they told us. The length is x. The width is x. And the height is x because it's a cube. All 3 dimensions are the same. That's the definition of a cube. We can simplify this. X times x times x just means x cubed. So that is the first part of our answer, because we had to write and solve the equation. So 27 equals x cubed is our equation. Now we need to solve it. So we have x cubed equals 27. How do we solve this? How do we solve it? How do we just get x, not x cubed? Well, remember back in our chart that x cubed right here, p cubed, we had p cubed on our chart. How did we get p by itself? Well, we go left, and that means we take the cube root. So if we take the cube root of p cubed, we get p. So if I take the cube root, radical with a 3, of x cubed, I should also take the cube root of 27. So the cube root of x to the third is x. The cube root of 27, looking at the chart, looking for 27, cube root of 27 is 3. So x is 3. So our answer, one side of the cube is 3 inches. That is our answer. So now we can solve linear equations like we practiced in other modules. We can solve equations with squared variables, and we can solve equations with cubed variables by using square roots and cube roots. So these are more skills for solving more complex equations. We're not just looking at linear equations anymore. You're looking at non-linear equations and solving them. This is going to be especially important in high school because you see a lot of non-linear equations in high school. Let's see what else they have for us. Here we go. More exercises. Exercise 5, 6, 7, 8, and 9. I think this is our last page of exercises. And we're still finding x. We're still solving non-linear equations. So x squared equals 64. That's the equation. How do I solve it? Well, remember, I need to do the inverse. So I take the square root of x squared. And that makes x by itself. I take the square root of x squared, and that gives me x because they're inverse operations. Kind of like multiplying by the reciprocal or adding the negative version. It's the opposite function. It's the opposite action. But it has to stay equal, which means same thing on both sides. So I do square root over here. I have to do square root over here too. The square root of 64 is 8 because 8 times 8 makes 64. So x equals 8. I do the square root to get x by itself. I do the square root to keep it equal. I get my answer. For exercise 6, it's not x squared equals 64. This time it's x cubed equals 64. Make sure you're paying attention to the details because that is going to change your answer. Because now if I want to isolate the x and get only one x, I don't take the square root. This is x cubed. So I need to take the cubed root. And the difference is there's a 3 here. So I take the cube root of x cubed to get x by itself. But if I do the cube root on this side, I have to stay equal. So I do the cube root on that side. And the cube root of 64, you can see from today's chart, the cube root of 64 is 4. Because 4, I'll even check it for you right here. 4 times 4 times 4 equals, because that's what cubed root means. It means multiplied by itself 3 times. 4 times 4 is 16. 16 times 4 is 64. So that's how I know the cube root is 4. Let's try this. Oh, it's getting a little bit tricky. You have to remember all the way back to Module 1 and our exponent rules for number 7. Find the positive value of x that makes the equation true. X squared equals 256 to the negative first power. Well, this is what we start with. X squared equals 256 to the negative first. But this is actually much simpler than it looks like, because you should remember the exponent rule for Module 1. The exponent rule means when we have a negative exponent, we need to move it to the other place in a fraction. So it's the reciprocal. So it's the reciprocal of 256, which means, let me remind you, that this goes into the denominator. So it's this 256 to the negative 1 means 1 over 256. Means 1 divided by 256. It just means put it in the denominator. Then it's the same step. This is x squared. So if I want x by itself, I need to take the square root of x squared. The square root of x squared makes x. So now I can find just x. But I need to do the square root of the other side also. Now you might be saying, Mr. Baylor, how do I do the square root of a fraction? This does not look fun. Well, let me actually move this over here to give myself some more room. To do the square root of a fraction like this, you can actually just do the square root of the numerator and the square root of the denominator. So like the square root of the numerator divided by the square root of the denominator. That's what you can do. That way you're not taking the square root of a fraction, you're taking the square root of the fraction parts. So let's do this. X equals the square root of 1 is just 1. And the square root of 256 is 16. It's on your chart. It's on my chart. You can trust me here. I'll prove it to you. 16 times 16 is 256. So the square root of 256 is 16. So now, instead of taking the square root of a fraction, I took the square root of parts of a fraction. So now this is the answer, 1 over 16. Or if you really liked, you can rewrite it with the negative 1. You can say x equals 16 to the negative first power. It actually is the same answer, because remember, all we do is when we see a negative 1, it just goes in the denominator. Both of these are the same. We just write them different ways. But to find the square root, we change it to a fraction, square root the fraction, find the square roots of the pieces, and then just write that down. And that's a good example to look at if you have any other questions in today's problem set or exit ticket, and you want to remember how to do this. Look at exercise 7. Exercise 8 is going to be the same thing, except for this time we're going to have a cubed root. So let's try it out. We have x cubed equals 343 to the negative first. But I just told you in exercise 7 that all that means is we're just taking x cubed and we're putting 343 in the denominator, like that. Now we really just want x. We don't want x cubed. We want to know what x is. So to find x, we need to take the cube root. That's why I did the radical with a 3 cube root of x cubed. Because the cube root of x cubed is just x. They're inverse operations. So the cube root and the x cubed cancel to make just x. But if I do it on this side, I have to do it on the other side too because this says equal. So the cube root of 1 over 343. Let me again move it over here so I have more room. And I just like when I did the square root of a fraction, the cube root of a fraction, I'm just going to do the cube root of the pieces. So what's the cube root of 1? Looking at your paper, you see the cube root of 1 is 1. And then what's the cube root of 343? The cube root of 343 is 7. So x is 1/7. Or you can say x is 7 to the negative first, because that's our exponent rule, and you know it means the same thing. So you can see how cube roots and square roots can help us solve equations with different kinds of exponents. And what we're building right now are your skills in solving different types of equations. Next year in high school, when you take true algebra and you start doing more algebraic thinking, you need these skills to solve a bunch of different types of equations. So that's why you're getting introduced to them now. Let's look at number 9. Number 9 is just asking, is 6 a solution to this equation? Explain why or why not. So what it's asking is, does 6 work here? Well, let's try it. Here's our equation. X squared minus 4 equals 5x. So can x equal 6 is what it's asking. Can x equal 6? Well, let's try it. Let's put 6 instead of our x's. And let's solve. 6 squared is 6 times 6, which is 36. 5 times 6 is 30. 36 minus 4 is 32. So the left side is 32. The right side is 30. 32 does not equal 30. So is 6 a solution? 6 is not a solution because, excuse me, when you substitute, the sides of the equation are not equal. So 6 cannot work because the sides are not equal. So therefore, it's not a solution. So that's what we're doing today. Let me show you again our exercises just so that you have an idea of where to look for examples. We started with how to find the answer to squared equations. We practiced with the square park. Then we did a solving a cubic equation. Then we actually found the measurements of a cube. Then we solved some more equations with squares and cubes. And we even did some practicing solving when there are negative exponents and you have to take the square root of a fraction. So lots of tools here for you to look at, lots of tools for you to use. Let's see what your problem set looks like. You have the lesson summary on page 28. You have the exit ticket on page 29, which I'll slide to the back. The homework helper on page 31 and 32, with more examples you can look at if you get stuck. And then you have the problem set on page 33, which is going to be a lot of questions asking you to solve equations with squared variables or cubed variables. So you're going to use square roots and cube roots to solve some equations. Sometimes you will write the equation and solve it. Sometimes they'll just give you the equation. And they'll ask you questions about this. So do your best on this. Remember, my answers to the problem set are posted online, so you can check your answers whenever you need to, just to make sure you are on the right track. If you have any questions, make sure you reach out to me for help so that I can help you answer whatever questions you have. When you feel confident you know how to do this, you go back to the exit ticket that was on page 29, and there are 4 questions with 4 different equations that you need to solve using square roots or using cube roots. And there's even some with the -1 exponents that you need to turn into fractions. So good luck with this, have fun with this, and work hard on this. And I'll see you for the next lesson.